Okay, so today I wanted to talk about something that I think a lot of students could benefit from, GCSE level, both foundation and higher tier, and that thing is dividing in a given ratio. So if I just switch to the whiteboard here, alright, that is our title, dividing in a given ratio. And what I'm going to do here, I'm going to show you a simple method that will help you understand how these work and can also be used to solve problems. And then I'll show you a more sophisticated method that can be used to solve more sophisticated problems. And you can decide what's right for you. So to see an example of dividing in a given ratio question, we should look at one like this. Divide 54 in the ratio 4:5. So 4 parts to 5 parts. And the simple method to approach this is to use boxes to represent each of the parts of the ratio. So if we were sharing this between two people, the first person would have 4 boxes because they have 4 parts of the ratio, and the second person would have 5 boxes because they have 5 parts of the ratio. And each box is worth the same. That's very important here. So each of these 4 parts and each of these 5 parts is worth the same thing, and that's all represented by the boxes. Now all we have to do is share the £54 that we've got out into all 9 boxes. So simply we're doing 54 divided by 9. Which is 6. And that's telling us that each box is worth 6. In this case, £6. So you can fill all of those in if you like. And the top row belongs to the first person, and the second row belongs to the second person. And so, by adding up the boxes, we can see that the first person gets a total of £24, and the second person gets a total of £30. And what I would encourage you to do is check your answer by making sure the two numbers that you've got add up to the total. And indeed, if we add 24 and 30, you get £54. So they do add up to the total. So that's a nice little check to make sure that we've done it correctly. Okay, so let's have a look at another example here. This is a worded question, but I'm going to approach it the same way. Kat and Lindsay share 30 cupcakes in the ratio 3:2. How many do they each get? Alright, so this time we've got Kat and we've got Lindsay. And Kat is going to get 3 boxes because she has 3 parts of the ratio. And Lindsay is going to get 2 boxes because she has 2 parts of the ratio. Remember, all boxes are worth the same. This time we've got 30 cupcakes to share out between the 5 boxes evenly. So I'm going to do 30 divided by 5, which gets me, funnily enough, 6 again. So each box is worth 6. This allows me to see how much they each get. Kat is going to get 18 cupcakes. Lindsay is going to get 6, add 6, 12 cupcakes. And we can just check. They do indeed add up to 30, which tells us that we've done it correctly. Now, I want you to pay attention to the fact that here we divided by 5, which was the 2 parts of the ratio added together. And that leads us into our more sophisticated method, which doesn't involve drawing the diagram and hopefully is useful for splitting up into larger and more complex ratios. So for instance, we'll take a look at this question. Gemma, Alicia and Omar have a combined height of 490 centimeters. If their heights are in the ratio 31 to 32 to 35, how tall are they? And you can see that using the old method, this would be very difficult because it would involve drawing out 31 and 32 and 35 boxes. So let's try the new way. How we're going to approach this is add up 31 and 32 and 35. So add up all of the parts of the ratio, and that's equivalent to adding up all of the boxes that we would have drawn if we'd done the box method. And if we do that here, we get 98. And remember what we did before. In each example, we simply were dividing the total by the number of boxes. And that's what we're going to do here. So I'm going to do 490 divided by 98, which I'm pretty sure is 5. And that's telling us each of our imaginary boxes is worth 5. Each individual unit of the ratio is worth 5. So then to work out how the height is shared out, I simply multiply the number that we've just got by each part of the ratio. So 31 times 5 is 155. 32 times 5 is 160. And 35 times 5 is 175. So in answer to our question, Gemma is 155 centimeters tall. Alicia is 160 centimeters tall. And Omar is 175 centimeters tall. We should check that those indeed add up to 490. So that adds up to 10. Carry the 1. 5 add 6 is 11. Add 7 is 18. Add 1 is 9. Carry the 1. 1 add 1 add 1 is 4. It does indeed add up to 490. And another small check that we can do, as we always should when it's possible, is to make sure the answers that we've got are sensible, which it appears that they are. I think the average height of an adult in the UK is about 175, and these people are roughly around that, which is a good sign. So let's try to apply that to a final worded question. A box of 48 chocolates contains dark, milk, and white chocolates in the ratio 2 to 7 to 3. Jeff doesn't like dark chocolates. How many of the chocolates can he happily eat? So we need to work out how many are dark, how many are milk, and how many are white. So to replicate the previous method, 2 add 7 add 3. I'm adding up each part of the ratio to get 12 here. Then divide the total, 48 chocolates, by that result. 48 divided by 12 is 4, which tells us each part of the ratio is worth 4. Each box in the ratio is worth 4. So to work out dark, milk, and white, we're simply going to do 2 times 4 to get 8. The 2 is coming from there. 7 times 4 for the milk part, which is 28. And finally 3 times 4, which is 12. Just add them all up to check that it works. 28 add 12 is 40, add 8 is 48. So we've got a total of 48 chocolates, and we must always, on worded questions, check that we've answered what the question is actually asking. So here it says Jeff doesn't like dark chocolates. How many of the chocolates can he happily eat? Well, if he doesn't like dark chocolates, that means he can eat the rest. 28 add 12, he can happily eat 40 chocolates. And there we go. So there we have a little summary of how to approach these dividing in a given ratio questions. For simpler ones and most of foundation level, the first method with the boxes is probably a good way to go. For higher level, when you're approaching more complicated questions, and especially when the ratio contains larger numbers, you're going to be wanting to use that second method. I hope that was useful. Drop me a comment if you have any further questions, and I would love to help. Thanks for listening.